A pump curve shows how flow changes with head or pressure. The horizontal axis is flow, usually in gallons per minute or liters per second. The vertical axis is head, typically in feet or meters of water column. Each curve represents the pump's performance at a specific speed. As the speed increases, the pump curve shifts upward. The system curve, shaped like a parabola, represents the resistance of the piping, valves, coils, and other components that the water must flow through. The point where the pump curve and the system curve cross is called the operating point. As valves close, strainers clog, or filters foul, system resistance increases. The system curve shifts to the left and the operating point changes. The pump now delivers less flow than before. If we need to maintain the original flow rate, the pump speed must be increased so that the new system curve intersects the pump curve at the required flow. In pump curves, there is also a highlighted or gray region on the far left side. This region represents unstable operation at very low flow rates, and pump operation in this region is not desirable. On most pump curves, you'll also see additional overlays. Brake horsepower line showing how much power the pump draws at different operating points, and efficiency curve, a smooth line that peaks where the pump operates most efficiently. To read the pump curve, start with your required flow rate on the x-axis. Move straight up to the pump curve. The point where you land is the operating point for that pump speed, and the corresponding head value shows the pressure the pump can provide at that flow. From that same point, you can read the pump's power and efficiency from the overlaid curves. Always aim to select the pump within its stable, high-efficiency region. This video is part of the HVAC Fundamentals course on AEC Learn. If you found this helpful and want to become an HVAC engineer, visit aeclearn.com. And don't forget to subscribe to the AEC Learn channel on YouTube.